Wildfire has been part of this research center from the very conceptualization of it, not as the leading thing, but as a, oh gosh, there's so much risk out there. We need to get ahead of this peril. The idea for Ember generators, it was really born of the research that was done by Jack Cohen and others. He could tell where the canopy fires were going, where the flames were going. And then you look at pictures of neighborhoods. You look at cul-de-sacs where there were still green bushes and trees all around and no houses. And so the idea was, no, it's not the flame front.
So really, there were some Ember generators that existed before, but they were really small laboratory scales that really could affect maybe a small section of a wall. And obviously here at the facility, we want to subject entire buildings to a realistic Ember storm.
Yeah, the first build of the Ember generators, there are a lot of weird things on the reimbursement list. At one point we had a dryer, like an actual clothes dryer. Because we thought, well, we need to dry the mulch. Let's try this and see how it goes. That was a terrible idea. I mean, it was part of the experimentation. Fail early, fail fast, learn, and move on.
And so we really had our first iteration of these Ember generators, and they were kind of like a set and forget, right? So you loaded all the burnt material into them and you would ignite it, and you kind of got what you got, and the duration of that Ember storm lasted as long as the material you loaded into it. We did a lot of testing in 2013, 2014 with that system, but it had a few drawbacks where, again, you were confined to a certain time duration. Once the fuel was used up in our individual hopper, that was kind of the end of the test. With this continuous feed system, we could get down to 5 minutes between tests, and so we can run 5, 10, 15 different configurations in a day, whereas under the old system, we might get 1, maybe 2.
And boy, it is fascinating and exciting and wonderful to see that we started with that system that was put together, rapid fire, let's figure this out, let's make it run. It functions the same, but as the team has improved and our numbers have increased and our throughput has gotten bigger, we're making that system better, more robust, and more capable with each time.
These improvements have been incredibly important to execute research projects, especially that continuous ability to create embers, because it's allowed us to do more tests in a shorter period of time.
Well, in the beginning, it was really just Justin and I in this shop here doing a lot of getting one Ember generator up and running.
My part in this was helping bring the project back to life, fabricating new parts, understanding old parts, and then trying to get to something that was repeatable and safe.
You take experiences that I, Justin, and the others had, and you ask questions, because you're going to come up with, oh yeah, this worked over here. Can we make it work over here? And then it's an elephant. You eat it one bite at a time.
So we had to start from scratch, really dive into how it was supposed to operate, what it was supposed to do, and then from there, construct components that would allow it to work repeatedly and not fall apart or get destroyed during the burn.
So I just had to sit down with Justin and Rafi and go, okay, can we get the igniter to cause a pilot flame? And that was the first step.
We had to completely re-engineer the ignition system. So we'll start with a jet burner, and then you start with a basic concept and you modify it as you go until you get the desired effect.
But trying to get controlled and repeatable is a real big challenge, and that just comes down to seeing what variables do what. I started here in this machine shop, just playing with different variables and seeing how they go, and then how do those variables act on a bigger scale. And
a lot of the projects here, if you go in just thinking this is how it's got to operate and all we got to do is put it together, it doesn't work that way.
And as a test engineer, as a prototype engineer, those experiences, you expose yourself to a lot so you can find something new, because there's not an off-the-shelf solution here at IBHS.
So there's a process of getting the Ember generators working, process of testing and making sure that all 6 Ember generators work together. Then there's a process of seeing them work together against a target.
The whole thing was challenging. running the pipes for the feed system for the mulch. And then that was a learning period too, because we figured that if we cut windows in, we could see if they were clogging in certain spots.
My role as a facilities manager, I also had to make some modifications to our utilities. So where the natural gas came in, we had to change the regulator so that we could get the proper supply of gas in the proper quantity, which presented a challenge.
So when we were building the Ember generators, Chris Gay needed a specific regulator. So I reached out to my brother, Jimmy Charles at Chester Gas Company, and he came through within the next day.
You know, I mean, when it came to controls, Rafi was a huge help. He spent a lot of time ironing out the details for me when it came to those controls.
So the Ember generator system basically is consisted of two main subsystems, which is the feeder system and the burners. So it started with the very simple program, and then they want some more options to be added to the program to have more control over the system.
You know, Lucas sat down and operated the laptop for us, and he would give feedback. Then Rafi and I would try to figure out how to get that back into the LabVIEW control program to make it good for him. So there's a lot of people working together to make this happen.
And then as it went, it became what it is now, where it was each individual generator was controlled individually. Each auger that loads the fuel in was controlled individually. All the fan controls were controlled individually.
So that was the main purpose of adding more options to the system for the operator to operate or just to activate or deactivate each components.
Every day before we run the Ember generators, we have a safety meeting involving all people, whether they be actual operators or just observers. So once we actually have the Ember generators built and lowered into the trench, it takes about 13 to 20 people to run the operation. And that includes your carpenters and your mechanical people, then also safety people, and then the actual operators.
So the Ember generators basically work off of the concept of using natural gas and compressed air to start a fire in the barrel assembly. And then we're using air and augers to push mulch, which is the fuel, to the Ember generators, and they just start burning there. And then finally, you have another fan at the bottom pushing those embers up as they get ignited and pushed out into the wind stream.
So this is the hopper, which we have fins coming in here so limited mulch can get through. These are your augers. This is the fan blower, and we can control the airflow to each pipe so we don't blow out the Ember generator, which in turn feeds all the way to each one. And we have sight glasses in so we can see if they're clogged up or not, which is a new feature.
So we have to walk up and down with one person monitoring each one, looking in for the fires, and the other person is at the laptop showing how much fuel is going to them. So we're trying to balance the fuel and the burn times so that we get a consistent Ember output.
It's usually every maybe 20 to 30 seconds there's some sort of adjustment, but it's more of just the fuel load in rather than or anything else.
This time we walked away with a lot more controls. Different aspects of the process were more automated. We could stop problems before they started. We could initiate things to help increase the effect of embers. And I'll say that was a big takeaway for me.
Once you get over that initial wow factor, it's such a realistic thing that we're able to reproduce here in the laboratory environment. Embers are prevalent on every fire, from just a small fire that's low intensity to a very large, high intensity fire. Embers that were produced here in the laboratory environment at the research center remind me of my experience when I was on the campfire, where it was about 4 or 5 hours into the fire when I was in Paradise and seeing embers igniting fires all around the town as I was driving through the town. Embers would continually flow in and around the structure, potentially igniting new fires, and that creates a challenge for firefighters on the ground. When you're conducting experiments, you want to provide for the most realistic exposure that you can so that the test results can then translate to mitigation actions that can be carried out on the ground. And what we're able to produce here in the laboratory environment with these Ember generators and expose a full-size structure and its immediate surrounding is very realistic to the exposure that we see in the field. It gives you a better visualization of what's happening in the field, what's happening during a fire, and helps you understand the complexity and the severity that the wildfires attack structures with. This is the only facility in the world that can do that.